So let's solve for df1 divide for the x1, for the x2, for I equals to x2, right? As we said in the coordinates. So df1 divided by dx, which also equals to df1 divided by dx2. Hear me out. So this is dx2. This could be d divided by d, j will be dx3, and this also can be d divided by dx1. Okay, so I equals to x2, right? I equals to x2. This is I, this is j, this is k. So that's why we are going to make df1 dx equals to df1 equals to dx2. If we're going to make for the k will be df3 divided by dx2, okay, and j will be df2 divided by dx1. And that how it goes. Everyone have his own way, so that's my own way. I'm actually making several types of ways to solve this problem. So that's why I made df1 divided by dx equals to df1 divided by dx2 for the I coordinate, which is the x2. Okay, and as we move on, df1 divided by dx2 equals to r divided by r3. So we'll take r outside so we can find the differentiation of the magnitude. It's going to be 1 over r3 multiplied by r. Okay, the next step we need to do is take the derivative of the 1 over 3 over r3. So it's going to be, r will be on the other side. R equals to x1 square plus x2 square plus x3 square. Okay, and df1 will be d divided by dx2 equals to 1 over r3. When we differentiate, it's going to be r minus 3. Okay, negative 3 r negative 4. So that's the derivative of the 1 over r3. Now we need to find the derivative of r. R actually equals to x1 squared plus x2 squared plus x3. We need to find the derivative of the r. So it's going to be x1 squared plus x2 squared plus x3 squared 1 over 2, right? And as you solve, to solve for dx, do it with respect to x2. So x1 squared plus x3 squared will actually equal to 0. And as you move it up for the chain rule, it's going to be 1 over 2 multiplied by, I will take this one down, it's going to be x1 squared plus x2 squared plus x3 squared minus 1. So it will actually equal to 1 root x1 squared plus x2 squared plus x3 squared multiplied by the respect to x2 squared will be 2x, respect to 2x. Now we multiply the half with the 2x will actually equals to 1. So it's going to be x2 divided by r, because that's the dr divided by the dx2. dx2 will equal to 0 because that's 0 plus 2x plus 0 and so on. Moving on again, df1 dx2 equals to minus 3r minus 3 r negative 4. Okay, equal to minus 3 divided by r4. Now we multiply it with r, as we said before, because we said df1 dx1 over 1 over r3 multiply with the r, the magnitude. You found the derivative of the magnitude, so it's going to be minus 3 r4 multiplied by x2 divided by r will actually be, because it's df1 dx2, we need to solve for the dx1, so this will be df1 divided by dx2 will equals to minus 3 x1 x2 divided by r power 5. R power 4 multiplied by r will equal to r power 5. So that's for the x1. The same thing we are going to do with the df2. Like for instance, that's the df2 divided by dx3. It's going to be minus 3 x2 x3 divided by r5. df3 divided by df1 minus 3 x3 x1 divided by r power 5. The last step, we need to combine it all in one row. And when we do combine it, it will actually equal to 0, because the terms will actually cancel each other. So it's going to equal to 0. That's it. Each term will cancel at each other. So note, when we say df1 divided by dx1, this will be respect to x1. If you have a magnitude, you're going to take the magnitude, the r of the magnitude, the derivative of dr with respect to dx1. So it's going to be x1, for instance, divided by r, and so on. Same thing with the df divided by dx3 will be the same thing. This will be with respect to x3, and so on. It's going to be x3 divided by r. That's how we take the derivative of the magnitude of the r, and we multiply it with the vector of the force, and we can find the answer when we actually combine it together. So we evaluated that the delta multiplied by r divided by r3 equals to 0. Will equal to 0.